2025 में पब्लिश हुआ है, जर्नल ऑफ डेरिवेटिव्स एंड क्वांटिटेटिव
अच्छा
स्टडीज।
अच्छा ठीक है, हाँ स्पॉट
इसमें मैम
शॉर्ट्स
आपने
एंड फ्यूचर्स
मेंशन
पे।
या इसमें आपने मेंशन किया हुआ है डाइबोल्ड एंड यिल्मास 2012। वहाँ
हम्म।
टीवीपी वीएआर मेंशन नहीं किया हुआ, तो मैम ये दोनों
हाँ
डिफरेंट है मॉडल, है तो
नहीं नहीं,
उसी के ही
मॉडल
वेरिएंट।
हाँ उसी के वेरिएंट है, तो बस उसका बेस मॉडल मेंशन कर दिया।
मैम उसमें मुझे यही थोड़ा सा कंफ्यूजन है मैम, क्या डिफरेंस है बेस में और उसमें।
मतलब बेस उसने स्टार्ट करा
जी, नहीं वो
तो
मेथोडोलॉजी मतलब रोलिंग होता है मैम, उसमें रोलिंग विंडो होती है शायद,
रोलिंग विंडो, हाँ रोलिंग विंडो होती है।
बेस वाले में होती है ना।
हाँ हाँ रोलिंग विंडो होती है, तो रोलिंग विंडो ली हुई है पूरे में।
जी बेस वाली, हाँ उसमें रोलिंग विंडो लिखा है, टीवीपी में
हाँ
नहीं होती मैम रोलिंग विंडो, है ना।
टीवीपी में भी होती है रोलिंग विंडो, वो तो आपके ऊपर है, आप उसको लेते हो नहीं लेते। अगर आप उसको स्टैटिक मान लोगे तो आप नहीं लोगे, वैसे रोलिंग विंडोज में भी होती है।
ओके, तो डिफरेंस क्या हुआ फिर मैम इसका, दोनों
वार
में।
बेसिकली वार स्टैटिक है और टीवीपी वार डायनामिक है। अगर आप वार लेते हो तो आप ये सोच के चल रहे हो आपका पूरा डेटा लीनियर है, ये चेंज हो ही नहीं रहा, जैसा आपने फर्स्ट डे स्टार्ट किया था सेम डायरेक्शन में चल रहा है वो लास्ट डे तक, ये चेंज नहीं हो रहा।
ओके, तो मैम जैसे हमने किसी जैसे पब्लिकेशन में मतलब सबमिट किया पेपर, तो उसमें वन ऑफ द लिमिटेशंस या वो पूछ सकते हैं ना एडिटर कि आपने ये
हाँ
क्यों
हाँ।
मॉडल यूज नहीं किया, ये क्यों किया।
हाँ
ओके मैम, मैम एक चीज और मैम, जो आपका बिल्कुल लेटेस्ट पेपर पब्लिश हुआ है मैम, उसमें आपने हेजिंग रेशियोज यूज करें।
ईटीएफ वाला।
यस मैम,
हाँ
2026 में ग्लोबल बिजनेस रिव्यू।
ग्लोबल बिजनेस रिव्यू, हाँ।
तो मैम उसका अगर थोड़ा सा आप ऐसे ही बता दें तो।
हेजिंग तो सिंपल चीज है, हेजिंग कब होती है आप बताओ।
हाँ मैम वो तो है, बट जो आपने रेशियोज में यूज किया और जो आउटपुट है उसका, वो थोड़ा समझने में वो हो रहा था मैम।
जबकि मैंने पूरा लिखा हुआ है उसके अंदर।
लिखा तो है मैम, उसको मैम कैसे करेंगे आर में मैम।
आर में आज वाला टॉपिक कर लें पहले।
अच्छा अच्छा ठीक है मैम, पहले इसको कंप्लीट कर लेते
हाँ
हैं मैम।
हाँ।
थैंक यू मैम।
कोई और डाउट किसी को?
Hello, hello, ma'am.
यस स्वागत।
Ma'am, I just want to know. Maybe I sound very silly, but I just want to know how these equations are being written. Like
हाउ?
paper of yours, where computational economics. I think that is the
यस।
journal, or there the topic is the effects of economic uncertainty and trade policy uncertainty on industry-specific stock markets equity. So there are certain equations under this wavelet multi-scale decomposition method.
हाँ।
So very difficult. It seems very difficult, ma'am. The science and the total equation is being written there. So it scares me, ma'am. Sorry to say this, but how it is being written?
With the help of Word document. In Word document, there is a tab named as Insert Equations. Now, with the help of Insert Equations, you can write all the equations. Any other doubt to anyone?
Sorry, ma'am. Bit of network issue is there.
Okay, so I was saying that in the Word document, there is a tab Insert Equations. Once you go to Insert Equations, you can write any equation. All the mathematical signs, everything is given over there.
Ma'am, not about how to write, ma'am. Ma'am, like the symbols you have used. I
So
think it is all.
that are there na in your symbols part. Every symbol is there.
So, how we understand, ma'am, which signs to use where, like.
In equations, whenever you write any equation, you are aware of the what the equations are saying, so it becomes easy. मैं तो रिग्रेशन की, जैसे मैंने आपको इक्वेशन सिखाई है, एक्स वाई जेड कोई भी इक्वेशन आप सीखते हो तो उसका मीनिंग सीखते हो ना। अच्छा फॉर एग्जांपल अगर मैं आपसे कहूँ एडीएफ टेस्ट हम स्टेशनैरिटी करते हैं, बहुत सिंपल सी चीज, तो उसमें क्या मतलब होता है, स्टेशनैरिटी का मतलब क्या होता है?
जी मैम।
स्टेशनैरिटी का मीनिंग क्या है? अगर आपको स्टेशनैरिटी की एक इक्वेशन लिखनी है, आप कैसे लिखोगे? आपने कभी एडीएफ टेस्ट की इक्वेशन देखी है? बहुत सिंपल, सिंपलेस्ट इक्वेशन है, क्योंकि हम सबसे पहले एडीएफ करते हैं। क्या कहता है एडीएफ टेस्ट, क्या कह रहा है?
ADF test is being done to in order to check the stationarity of the data, ma'am.
स्टेशनैरिटी, हाँ, ये अब आपको पता है, स्टेशनैरिटी को चेक करने के लिए हम एडीएफ करते हैं। लेकिन ये स्टेशनैरिटी क्या है?
Stationarity, we can say कि like the data is ready for analysis or not, whether there are certain abnormalities or outliers in the data.
हम बस that is the meaning of this. This is the only meaning for stationarity.
मीन जीरो एंड
मैम
कांस्टेंट
मीन
वेरिएंस।
वेरिएंस को हम वो
Mean
मानते
zero
हैं कि
and constant
कांस्टेंट।
variance. Anything
यस
else? Anything else?
एंड ऑटो कोरिलेशन also remains same.
Stationarity, the main meaning of stationarity is mean reverting. Whenever we make the return diagram, see, we have two types of diagram: price diagram and return diagram. Price diagram has having a trend, it has a drift. When we did arima, I told you that must be there. If you are doing a price analysis, that means you are forecasting the price, you have to include the drift. But if you are forecasting the return series, drift can be zero, that means there can be a zero, your constant will be zero in that case. So whenever we are talking about ADF test, ADF stationarity, price data is not stationary. But why price data is not stationary? Because it's not mean reverting. As you were saying, mean is constant, we turn it as zero. So that means if any shock is increasing, if the prices are increasing, then it will decrease also. If any price is increasing, it will decrease too. If price is not increasing, if price is decreasing, it will increase too. So that means if price increases, decrease, and if it decrease, it increase. So that means it will move to zero. Zero will come. It is mean reverting from negative to positive and positive to negative. Okay, so that means we are saying that that means today's price or today's volatility is depending on its past. So, and we are also saying that past should be not persistent. That means the effect of your lag variables of your past, T-1, T-2, T-3, should not be persistent. It should decay. Now, when it is decaying, so what do you mean by word decaying? Yes, what do you mean by word decaying?
मैम पास्ट का जो भी वैल्यूज कोरिलेटेड हो रही है उसका जो असर है वो बहुत ज्यादा
Effect, if that means the effect of past is decreasing. So whenever we write the equation in ADF test also, so we write yt is equals to constant plus yt minus 1 plus error term. So we are aware of the equation that what we have to write, and the same case goes with your wavelet also. We are aware of the equation that what the equation is saying. So we write it. In wavelet, you must have seen, I did cross wavelet, then we did wavelet coherence, then I did partial wavelet, then I did wavelet correlation. So this is the process. Okay, let's start. Okay, today we
Yes,
have
ma'am.
to first of all we should do wavelet or we should do quantile.
Ma'am, quantile QVAR. That I
Huh,
think
quantile.
that okay, ma'am. That we did yesterday also, I think, ma'am.
No, we did QVAR, quantile vector auto regression. Now we
Okay,
have to do quantile regression, quantile ADF, and your quantile on quantile regression.
मैम पहले
And
वेवलेट कर
पहले
लेते हैं मैम।
क्वांटाइल
Yes,
कर
ma'am.
लेते हैं,
हाँ,
क्वांटाइल ऑन क्वांटाइल रिग्रेशन एंड क्वांटाइल मैम।
Okay, so we have to cover both, and we
सर
have a limited time. So first of all, let's start with the quantile. Now, can you tell me what is quantile? What is quantile?
Yesterday, ma'am, you had explained that
Hmm.
we split our our in across quantiles we make a split, and lower quantiles are bearish behavior, and higher quantiles are bullish behavior, and median quantiles means not much movement. So we split
Calm movement,
market calm,
movement.
calm.
Yes, yes. Okay, so that means what we have done, we have divided the market. See what we are doing in wavelet. What is wavelet? We are doing both the things together. Just try to understand what is wavelet. What do you mean by word wavelet?
It shows the heat or more impact of something.
Ma'am,
Okay,
wavelet
what?
generally covers all the trade cycles like recovery, recession. What I
Hmm.
could
See,
understand from wavelet.
see, wavelet comes from the word wave.
Wave,
Now,
yes.
what do you mean by wave? Waves are high tides also, waves are low also. Whenever we go to the seashore, we see the wave. Waves are high tide, waves are low tide. So, waves means how quickly you are analyzing and how slowly. For example, if I am saying any word, if let's say I am saying your name Mohan, so I can say Mohan, I can say Mohan. So that means it's depending on your wave, what you are saying. So expansion of your voice, expansion of your noise is known as wave. So wave, if you can see, do you understand oscillations? Whenever we make waves, waves can be this way also, and waves can be this way also. Okay, that means depend on the speed of wave. So what we did in waves, we have the frequency, that means dimension, starting from your 1 day till 1 year, last day of the year. So what we did, we make it vertically. That means on y-axis, we started from the first day of the month till the last day. What we are doing in wave, we are saying whether the effect is short term for a few days, whether the effect is medium term, or whether the effect is for the long term throughout the year. So we have divided the vertical line in three parts: short term, medium term, and long term. We define short term on our own. We say that the short term means maybe your 1 month, maybe 2 months, maybe 3 months, and medium term can be 3 to 8 months, and long term means your beyond 8 months till 12 months. So for the year, we are dividing into three parts. And if you are having a data for 5 years, so that means for every year, we are dividing the data into three parts: short term, long term, and medium term. So what the wavelet do? It divides the year into short, medium, and long, as well as it will show you the x-axis, the years. So that means what does the wavelet diagram is giving you? 2D diagram. On one side, years are there. On second side, short term, medium term, and long term is there. So it is giving every year how much the data is short term, how much is a long term, and how much is a medium term. Now, what is quantile? Now, in this quantile, we are also dividing your variable into many parts. See, in wavelet, simple wavelet, we can do quantile wavelet also. I'm just telling you the word meaning of quantile. Whenever you are making 2D diagram, that means one side year and one side your short term, long term, and medium term. And in quantiles, what we did, we divide the variables into different parts. We didn't divide the time. In wavelet, you are dividing the time: short term, long term, medium term, and for every year. In quantile, we are dividing the variables. That means how the variables behave. We are not saying that variable is behaving in a short run, medium term, and long term. We are saying behavior of the variables are also different, irrespective of time. It does not mean that suppose January is there. So in January, the market can be more volatile, market can be calm, market can be less volatile depending on some external factor. Now quantile means division of variables. Wavelet means division of time, frequency of time, short run, medium term, long term. So these are two different things. Now, whenever you are merging these two things, In that case, we can say quantile wavelet. So whenever we are making quantile, we can make a 2D diagram also. We can make a 3D diagram also. One side x-axis, one side y-axis. That means on one side one variable, on second side second variable, and on the height, that means dimensions, third side to be your quantile. Got it? Now we are dividing quantiles into different parts. The first thing is quantile regression. Second thing is your quantile on quantile regression. Everything is regression. Now, what is the meaning of quantile regression and what is the meaning of quantile on quantile regression? Anyone?
Ma'am, quantile regression would be linear and quantile
No,
on
both are non-linear. See, quantile, what do you mean by regression? In regression, we have dependent variable and independent variable. Now, what quantile regression is saying? Quantile regression is saying how independent variable is behaving on different quantiles of dependent variable. Got it? That means what we have done in quantile regression, we have divided the dependent variable into different quantiles, but we have taken the average of independent variable. For example, let's say I will import one of the file. I have given
Please
you
share your screen.
The screen.
okay, my screen is not shared. Okay. I thought I have already shared because I was writing over there. Okay, now it's visible.
Yes, ma'am.
Yes,
Okay,
ma'am.
now see, we have two parts, quantile regression and quantile on quantile regression. So quantile regression means dependent, in regression we have dependent and independent variables. So quantile regression is saying how independent variable is behaving on different quantiles of dependent variable. Now what we have, let's say I'll just import my one of the file and I have given you the file name to be the carbon credit. Okay, see, now this is my file. This is carbon and this is aluminium. Okay, I have given you one of my paper on this also. Okay, so what these variables are saying in this paper, what I have done, I have taken the precious metal and non-precious metal. For example, precious metal will be your gold, silver, platinum, and non-precious will be your aluminium, zinc, your nickel. Okay, so what we have seen, all these variables are explaining or they are incurring the carbon. So that means for carbon emission, these are the variables that are affecting. So we have seen the effect of your precious metals and non-precious metals on the carbon. Now, see what quantile wavelet is saying, quantile regression is saying, does your aluminium is affecting to the carbon when the carbon market is stable? How the aluminium is affecting when the carbon market is less volatile? How this aluminium is affecting when carbon is more volatile? That means when the carbon is in bullish part, when the carbon is calm, and when the carbon is in the bearish part. So how aluminium is impacting in these three regimes of carbon. Got it? What is the meaning of your quantile regression? Now in this, aluminium is linear, but carbon is non-linear. So we are saying how one linear is impacting the different linears of non-linear equation or non-linear variable. Any doubt in this? This thing is
Ma'am,
clear?
can you please repeat the explanation?
Now see, let me write it. Now what we have done, in this we have divided, you can say 0.10 carbon. We have written 0.50 carbon and 0.90 carbon. Okay, now 0.10 carbon means when market is bearish. Your 0.50 carbon means when the market is calm, normal situation. And 0.90 means when the market is bullish. Okay, now what I am saying that bearish market is equals to your alpha plus beta aluminium plus some error term. Second is calm market is equals to alpha plus beta aluminium. That means my next variable plus your error term. And bullish market is equals to alpha plus beta aluminium plus your error term. So that means what I have done, I have made the three equations, and in all the three equations, carbon is divided into three different regimes, but aluminium is not divided into three different regimes. So this is known as your quantile regression. In quantile on quantile regression, what we have done, we have divided your carbon also in three markets and your aluminium also in three markets. That means when the market is low for carbon, or you can say your bearish market, bearish carbon, your bearish carbon, your normal carbon, calm carbon, and your bullish carbon. And similarly, what we have done, we have divided in three parts your aluminium, your bearish aluminium, your normal aluminium, your, you can say when the market is calm.
So, ma'am, there will be 6 combinations, right?
Aluminium is calm and your bullish aluminium.
Ma'am, can you
9
share your
combination.
screen? It is not visible again.
I think 9 combination will be there.
9.
Yes.
So
Yes.
what it will be? How the bearish aluminium behave when carbon is bearish, how bearish behave when carbon is calm, how bearish aluminium will behave when the carbon is bullish. Then how the calm aluminium will behave when carbon is bearish, calm and calm, calm and bullish. Bullish and bearish, bullish and calm, and bullish and bullish. So I have divided into only three parts. In this way, we can divide it into 10 parts, 100 till 100 parts we can divide. But we are not able to write 100 parts in a research paper. So we normally divide into maximum 5 parts. Got it? So this is
5 parts में
quantile.
कैसे होगा मैम, जैसे 3 parts हुए हैं अभी?
So
Ma'am, can
bearish,
you show us, show that combination, please? We are not unable to see screen actually. So,
yeah, I'll show you. First of all, let's just understand what the
Screen.
regression is and what this quantile on quantile means, and then we will go with the this diagrams also. Okay, now this part is clear. What do you mean by quantile on quantile, and what do you mean by quantile? Now in quantile regression, one variable is non-linear, one is linear. But in quantile on quantile, both the variables are non-linear, because it does not matter. That means we cannot say that when the market will behave in all the three regimes, we name it as a regimes also, in the similar manner. That means if the market is bearish, its behavior will be different. When the market is calm, its behavior will be different. But when the market is bullish, its behavior will be different. So that means we are dividing this complete variables into three different regimes. and it will behave differently. So that's why we say it's a non-linear equation, non-linear regression. Now see, whenever it is a non-linear regression, the first thing what we have to do in any regression, we have to check the stationarity. So similarly, we have to check the stationarity in this also. But we have checked the stationarity with the help of ADF test. What does the ADF test say? ADF test says when the p-value, you have seen the p-value, when the p-value is less than 0.05, we say that data is stationary. But when the p-value is more than 0.05, we say the data is not stationary. Plus, whenever you are doing this ADF test, we think of linear equations only. That means linear means the data throughout the time period, whatever time period you are taking, it's same throughout. It's not changing. Its behavior remains same. But now in non-linear, we are saying the behavior will change. So that means in this we have to, since we have divided into three parts only, so that means the behavior, that means non-linearity, stationarity will be different in bull bearish market. It will be different in your calm market, and it will be different in bullish. That means it can also happen that your variable is stationary during bearish, non-stationary during calm, and non-stationary during bullish. Or it can be non-stationary in bearish but stationary in calm and bullish. So whenever you find these kinds of equation, that means it is stationary, it's a combination of stationary and non-stationary. We name it as a non-linear equation. Got this thing? So let me just show it to you. Let me attach the file. Okay. Okay, now what we are doing, we have different libraries. So you have to library quantile regression. The first library is QuantRec, quantile regression, ggplot2, reshape2, and plotty. These three are libraries for diagrams. So QuantRec and these three libraries for the diagram part. Done. So data is already imported. Now, first thing is we are going to check the stationarity. Okay. So now the first, what we are going to do, let me just name it to be data. I'm just naming data is equals to, I'm not going to write carbon credit again and again. I'm just giving the name data. Now see over here, the first thing I have given y is equals to data and the first name. That means we have to check the stationarity for each and every variable. We have different variables in this file. We have different variables. So we have to check the stationarity for all the variables. So first of all, first variable. So let's say y is equals to data, $sign, and your global carbon. Now what I have done, instead of writing global carbon again and again, I have just given the name y. There is no need to write global carbon again and again. Now, what do you mean by stationarity? As I told you, stationarity means it should be mean reverting. That means if it is positive, then it should become negative. That means it will go down. And if the variable is going down, again in the next time it will go up. Mean reverting. It will pass through zero. So that means we are saying that previous term, that means lag values, how the lag values are impacting my today's variable. So my equation is yt is equals to alpha plus yt minus 1 plus error term. How the previous lag is behaving to my today's variable. Now what I am saying, first of all, I have to create the lag values, y lag, because it is a relationship between yt and yt minus 1. Till here it's clear or not? Any doubt till here?
No, ma'am.
It's clear. So first of all, let me create the lag value. So see what I have given. I have just given the name y underscore lag is equals to lag of y minus 1. Whenever you take the lag value means previous term. So we have to do minus 1 means take the previous lag. If I have to take 2 lags, I will write minus 2. So I am taking only the previous lag. So y lag is equals to whatever is the value of y minus the previous one. The minus 1 means take the previous one. Okay. Now, if there is any n term, so what I have done, I have just removed the n term in this. Now see what I have taken. Remove an term from where data dot frame we use data dot frame when we have to combine two things. Now in regression, there will be two variables. One will be yt and one will be yt minus 1 because our equation is yt is equals to alpha yt minus 1 plus error term. So two terms are there, yt and yt minus 1. So see, I have taken one. First is yt, yt and yt lag. So there are two variables. I have just combined these two variables with the help of this command. Now I have given quantize. That means give me the situation when the market is in the low regime. 0.10, little bit higher regime. That means your bullish market. I have taken at different quantiles. So let me see how we are going to divide at bearish, calm, and your bullish. So I divide the quantiles 0.05, 0.1025. You can divide till 100. That means you can take 0.01, 0.02, 0.03 till 0.99. So we name it as cows. So we have divided into different quantiles. Now we have to run the regression ADF. So see, the name is quantile ADF test. So you just have to remember quantile ADF test. This is an extension of ADF. Let me just click the command. Now see what it has given. Now you can see this is a regression where yt and yt minus yt lag. That means how the previous value of yt is impacting the today's at different quantiles. And I have given take the data from this df underscore adf because I have stored it in df underscore adf. And now it will display you the results. Now these are the results. Now see. Now let's first of all see with the 0.05 quantile. That means when the market is bearish. Now you can see the lag coefficient is plus and lower bound and upper bound is, you can see over here, we are not going for intercept. We will go with the y lag. How y previous lag is depending in today's term. How the effect of the lag is in today's term. Now see, we have to see that this sign should be minus. Can anyone can tell me why the sign should be minus? The coefficient sign should be minus. If the coefficient sign is minus, it will be treated as your stationary. But if the coefficient sign is in plus, it will be treated as your non-stationary. Anyone? If anyone can tell me.
The gap is reducing if it's negative.
Yes. Then how? When the negative sign is gap is, it's not reducing, it's mean reverting. Now see,
Please
let me
could you
write it.
repeat the question what you have asked?
I'm saying that coefficient of y lag, that means y lag, you can write yt minus 1 should be negative, but right now it's positive. Whenever it is positive, we name it as an insignificant. Whenever it is negative, we name it as an significant. Why I am saying the coefficient should be negative? Why the coefficient should be negative? Why the coefficient should be negative? Now let's see what we are saying, mean reverting. If let's say my series is 10 and first the return is, let's say, 10%, or the it's 10. Now I am saying it's 10. Now it will go down. Let's say if it is going down, it should be 5. And again it is increasing, so it's 10. Again it is decreasing, 5. Again it is increasing, 10. Now see, if the all the signs are positive, so I cannot say mean reverting. It has not crossed 0. Whenever we make the return series graph, you have observed the return series means your bad changes, bad effects and good effects, and it will pass through 0. Mean reverting. Whatever is a mean, it is going back. It is just crossing the 0. But if the all the variables are positive, it is not crossing the 0. Then how it will be negative? Let's say over here we are saying y is equals to alpha, or you can just write yt minus 1. Okay, now if the value coefficient of yt minus 1, we are saying about the coefficient of yt minus 1. If the coefficient of yt minus 1 is negative, let's say minus 5. So, and yt is 10. Previous day value is 10 and coefficient is minus 5. So that means it will be 10 multiplied by minus 5 is minus 50. So the next value is minus 50. And now again the value will be, let's say the value is now negative. Value becomes negative, minus 50. Now my coefficient again comes to be minus 10. So minus 10 into minus 50 will be plus 500. So that means you will get one value negative, another value positive. If now positive is multiplied by the negative term, it will again becomes negative. Now again negative term is again multiplied by negative term, it will become positive. So that means what you are saying, one is negative term, one is positive, one is negative, one is positive. It means it is crossing 0. It is crossing 0. And when it will cross 0, when the coefficient will be in minus sign. If the coefficient is in plus sign, your values will be, if plus multiplied by minus term will be minus, plus multiplied by plus term will be plus. So over here, when it is negative, it's mean reverting. So we just have to see this sign. Over here, you can say it's positive, so it's not significant. The data is not stationary at this quantile. Plus, second thing, what you have to see, it should, these two signs should be similar. These two signs should not be it should not be of negative and positive, either negative, negative or positive, positive. Most probably negative, negative. So at 0.05, data is not stationary. At 0.1, again, the data is not stationary. Now see, at 0.25, the data becomes stationary. Its negative sign, it's become weak stationary because these are two are not negative, negative. It's weak stationary. Again, weak stationary, weak stationary, weak stationary. And over here at 0.95, strong stationary. Both the signs are negative and this is also negative. Now you can see that there is a combination of non-stationary, weak stationary and perfect stationary. So that means you have different regimes in this. So this is known as this also gives you that idea that your series, your variables are non-stationary. Your variables are non-linear. So these are the ADF test of non-linearity. This is how we will show the non-linearity. Now, first of all, this part.
Then
Yes.
what is the significance of taking a quantile 0.05, 0.95, 0.25? Can you explain that?
0.05 means when the fluctuations are less. And we are taking the calm market, it's up to us that whether we are thinking calm market from 0.25 till 0.75 or 0.4 till 0.6, it's up to us. So we are saying when the market is calm. Let's say you are saying, let's say your C. You will see the C is at a calm situation. Sometimes the sea is very calm. Sometimes in the sea, high tides are there. Sometimes there are low tides. That means whenever you are seeing any sea, we have three different situations. Low tides are there, normal situation, calm, and high tides are there. So the same way we have divided our variable into three parts, our stock market into three parts, that when the market is in a calm, nothing is happening. And when the market is highly regime, that means when the market is bullish, when the price increases, whenever in any market the price will increase, there will be more fluctuations. And whenever there is a decrease in the price in any market, there will be less fluctuation because people will not take out their money. Whenever the market is going, let's say your stock price is going down by 2 rupees, you will not take out your money. But if suddenly the prices increases, the fluctuations will be there. So it's up to us that how we are dividing the market. Now see over here.
Sorry to interrupt, ma'am. Is there any rule of thumb to suggest from 0.05 to 0.25? We will
Normally we take 0.1 till 0. Or you can say 0.20 as a bullish market.
till 0.20.
Till 0.20 or maximum by 0.25. That means what we have divided 0 till 0.25 as a bullish market, 0.25 or by 0.30 till 0.70 as calm market, and beyond 0.80 till 1 as a bullish market, where the
Okay.
fluctuations are more there.
Ma'am, this is also known as a fat tails, something
Yes,
like
fat
this,
tails,
ma'am.
fat tails, heavy tails, fat tails. That means when the
This.
market is bearish, bullish, it will be fat tails.
Okay. Thank you.
Now, let's go with the quantile regression. Now, dependent variable is carbon, as I told you. Aluminium is my independent variable. So now what we are saying, how aluminium is affecting the different regimes of carbon. So see over here, I have divided only in three parts. Lowest quantile, your, I think I have just written it wrong. The sequence should be 0.5 and 0.95. Okay, so these are the three situations. 0.05, 0.5 is median, calm market, and 0.95. So let's run it. And again, your normal equation, your how carbon and tilt sign and aluminium, how aluminium is affecting the carbon at different taus, and the data should be taken from the data one. So let's run this. And your summary of a model. Now C coefficient. Coefficient is positive but weak stationary. Weak p value is a weak one. Now you can say insignificant. These values are insignificant. What does it mean? That when the market is bearish, aluminium is having no effect on your carbon because it's insignificant. And if we move to, okay, let me change it to 0.95 and 0.0.
Ma'am, 0.05 is repeating, ma'am. No?
I have just given it 0.5 and 95 at different size. We are getting it 0.05, but okay, let me give different tau over here at 0.5. Now see over here. when it is 5. Now, in this case, you can say it's negatively affecting. It is negatively affecting. That means the data is significant over here, but it is negatively affecting the carbon. So you have to take different cows and then decide that how the behavior is there. Now, if we come to your plot, let me just change it over there. Otherwise,
In this case, we have just changed it for one of the variable or both of the variables.
both one variable is quantile. We have taken quantile for one variable, and we have not taken the quantile of the other variable. Okay.
Yes, we are just changing for one, right, ma'am?
Yes, we are changing for one only.
And ma'am, can you please share all these codes?
Yes, I'll share. Now see over here.
Yes, so that we can provide.
Yeah. Now see, I got the all the quantiles. So where the command is take from 0.5 till 0.95 and again till 0.05. Now see, at 0.5, at 0.5, okay, I have taken from 5 till 0.05. So at 5, that means when the market is calm, you can say the sign is negative and this is significant. I told you how we check the significant. These two should be negative. So it is significant. That means aluminium is negatively affecting the carbon when the market is calm. When the carbon market is calm, in that situation, aluminium is negatively affecting the carbon. Now, in again, when it is 0.55, also it is the same situation. It is negatively affecting and the value is significant. Now, you can see till this part, till your 7. I told you now we take till 7 as a calm market. So till 0.7 quantile, the value is negatively affecting the carbon and it is significant. But beyond from 0.75 when the market becomes bullish, it is affecting, negatively affecting, but at the weak point. Weakly affecting. It's not strongly affecting negatively. Negative answer is there, but weakly. But in the case of calm market, it is strongly negative.
मैम ये 0.75 वाला एक बार इंटरप्रिटेशन और समझा दिए मुझे, ये समझ में नहीं आया मेरे को ये 0.75 वाला.
In 0.05 your variable is negative and we are saying whether a variable is negative, it will be significant, right? And when the variable is positive, it will be not significant. When your coefficient becomes positive, that means your independent variable is having no effect on the dependent variable. But when it is negative, we are saying that your independent variable is having the negative effect on your independent variable. But see over here, the values, that means lower bound and upper bound, are not of same sign. So these two should be of the same sign. If they are of the same sign, then it will show that the significance level is more or not. We take the significance level at 0.10 also, we take the significance level at 0.05 also, we take the significance level at 0.01 also. If it is at 0.01, we can say that only 1% error is there. Whatever we have find out, that is, we are strongly confirming that. That means we are confident on that. But we can take 0.10 also. So 0.10 means 10% error is there. We are 90% sure. So this is defining weakly. That means you can say significance level is 0.10 over here. But when both are negative, the significance level is 0.01. So
मैम
it is
जो
strongly.
सॉरी मैम, जो साइन एक जैसा होना चाहिए वो पॉजिटिव भी हो सकता है या नेगेटिव भी, या सिर्फ
Yes,
नेगेटिव?
but we have to see the mainly the negative sign. It can
एंड
be
मैम
positive also.
ओके, इसकी सिग्निफिकेंस कैसे देखी मैम आपने? जैसे पॉइंट 05.
I have not seen the significance level. I have
ओके
just told you, just a
ओके
presumption that it can be strongly significant and weakly significant. Got it? Now, if I'll do it
Yes, ma'am.
0.05, so it will give me the answers from 0. It has given me from 0.5. Now it will give me the answer from 0.05. Now you can see. See, it is giving me the answer from 0.05. From 0.05, the coefficient is positive. So that means it is insignificant. It is insignificant. Or you can say over here, now see over it, the coefficient is negative, but weakly significant. Negative, weakly significant. Negative, strongly significant. But see, at different regimes, the ADF test is I'm saying this regression is showing me the different results. So it is showing that your data is non-linear. If it throughout it is showing the same effect, so that means I can prove that my data is linear. Now my data is non-linear. When the data will be linear at different quantiles, also your result should be same. If the data is non-linear at different quantiles, your results will be different. Now let's go with the quantile plot.
मैम एक चीज पूछनी थी मैम, ये कितने उस पर सिग्निफिकेंट है, मतलब 1% पर या 5%
No,
पर, वो कैसे?
you cannot say this.
ओके,
Now see
और
the
मैम
diagram.
जी जी
Now see the diagram. Now over here we have different quantiles and here is a beta coefficient. Now see over here when the beta coefficient is more than 1, not significant. And over here from till 0, you can see over here when the market is little bit calm, your answers are significant. When the market is more volatile, either less volatile or more volatile, your data becomes insignificant. So it is showing that your data is non-linear. At different quantiles, it is behaving differently. So your data is non-linear. You have never seen the heat diagram of quantile on quantile. I have given my one of the paper also where I have used quantile on quantile. I think so. Just check for ETF also. I have made the diagrams for quantile on quantile. Blue color, orange color diagram. Quantile on quantile wavelet.
Ma'am, right now we have applied only quantile, na, because we were changing only one
Yes, we have
variable.
just applied. We have just applied the quantile. Now we will go with the quantile on quantile when we are going to change both the variables. Now we are taking only two parts over here. For example, your X and Y. We are taking Y and X. For Y means your carbon and X means your aluminium. Now we are defining the quantiles. Again, I need the answer from 0.05 till 0.05. So I am defining the quantiles, both the quantiles. I am dividing QY also and QX also. Now matrix, we have to make the matrix in this because one will be row and one will be column because we have two variables. Now quantile for quantile, we are making different quantiles for X and similarly we will make for Y also. And let me make the diagram. Now, are you able to see this quantile on quantile regression? This is my heat map. Now, what they are saying, when the market is calm, quantiles of Y, quantiles of X. This is your 2D diagram. And let me make the 3D surface also. Now, are you able to see the 3D surface also?
Yes, ma'am.
yes ma'am.
So XC, you can see this X means your variable we have taken X as a variable of, I think I have taken, we have defined, see X is my aluminium and Y is by my carbon. So X is showing your aluminium aluminium at second quantile and your carbon at 0.25 quantile, and your Z coefficient is 0.27. Now you can see each and every coefficient. Z means coefficient. Now see over here. When your X is 0.90, that means bullish market of X, and bearish market of Y, your coefficient comes out to be 0.15. Now see over here. Your X is 0.5. That means when X is calm, but Y is bullish, your Z is, the coefficient is 0.13. Similarly, see over here. When your both the markets are calm, X is 4 and Y is 4, your Z becomes negative. That means it is affecting negatively. It's a significant result and it is affecting negatively. X is negatively affecting the Y. X is your aluminium, Y is your carbon. So aluminium is negatively affecting the carbon when both the markets are in a normal situation. But when one market is at the high situation, when the see both the market are at high, see 0.8 and 0.6 and 0.9. So when the one market is calm, another market is high, then also it is negative. Now see where it is, still where it is negative. So now you can say that X is behaving negatively at different quantiles of Y. Y is 0.9, Y is 0.9, Y is 0.25. See, you can just see when both the markets are in the bearish form, there is no impact of aluminium on your carbon. So in this way, you can just see the diagram and write your results.
Ma'am, through which command we have got this?
From this Plotty Y is one of the library. From with the help of Plotty Y, I have made this diagram.
Ma'am, results we need to
Ma'am,
report like you just showed us by
Yes,
clicking
yes, yes,
everywhere.
yes, yes. You have to just show it right like this and you can just write it.
ma'am, I was asking, but in the commands we did not specify different levels of both the
No,
variables.
we define now. See,
Ma'am, can we not get the
see, we
results in a
define.
table format?
You will not,
Okay,
you can
ma'am.
give,
So this was
it's
the
up to you.
specification.
See, these are the specification that for Y series take from 0.05 till 95 and then till 0.05. Again from
Yes, ma'am. Got it.
0.05 till 95 till 0.05. We have specified. If suppose I have taken it 0.5, I have started with 0.5. So that means I am saying from calm market till bullish market only. If I am saying from 0.05 till 0.5, it means from bearish to calm market. Now I am saying from bearish to bullish and calm will become in between. There are different ways to represent the quantile regression. One way is this 2D diagram also you can explain. This is your 2D diagram, this was your 3D diagram. So it's up to you how you are going to present it in the paper. Even we can make it with the heat map. Whenever you are using the heat map, you can say quantile on quantile wavelet or quantile on quantile wavelet.
मैम वो कैसे
And
बनाएंगे मैम इसका हीट मैप?
heat map की भी command है. I can just show you the heat map, how it's look like. I'll just show you. See, are you able to see this diagram?
Yes ma'am.
Yes, ma'am.
This is quantile on quantile. See, this is, I can do quantile on quantile in different ways. For example, Granger causality, you have heard about, we can do in linear model. We have done ARDL model, linear ARDL model. I can apply Johansson co-integration model. Now, this is quantile on quantile Granger causality. Similarly, if I'll show you, this is quantile, average of quantile regression versus quantile on quantile regression. Okay, and this is quantile on quantile regression. This is quantile on quantile regression heat map and quantile on wavelet quantile code. This is wavelet quantile. Now you can see the diagram will be heat map like this, but one way I have taken quantiles and another way periods. ये थोड़ा सा गलत हो गया. I must have written quantiles over here and periods over here.
Ma'am, what is the code for this wavelet quantile correlation?
There are different codes. Everything is made with the codes only. The only thing is you should be able to understand, you should be able to read all these things. I have sent you one of my paper where I have made the 3D diagrams for quantiles also. So it's up to you how you are going to show the quantiles. Okay, should we move to the wavelet? I'll be sending you all these commands.
Yes, ma'am.
Okay, now when we talk about wavelet, we have two kinds of wavelet. One is cross wavelet. So first of all, we will be discussing the cross wavelet. And second will be your wavelet coherence. What is the difference between these two? What is the difference? Cross wavelet and wavelet coherence, and third is your partial wavelet. What is the difference? Anyone? Anyone has not applied wavelet till yet?
No, ma'am, not yet.
What
No,
is
ma'am.
cross wave? Cross wavelet. What do you mean by what
No,
cross
ma'am.
wavelet? What is cross wavelet? Cross wavelet is see. If I talk about in simple language, cross wavelet and wavelet coherence is just like covariance and correlation. As I told, we were discussing yesterday, what is covariance? Covariance is just telling whether the two variables are having the same strength or not. So that's what the cross wavelet will tell you. We will be taking two variables, we will just measuring the strength, but it will not give me the magnitude. Yes, it will show me, yes, both are moving together or both are not moving together, but how much, whether they are significant or not, and in which variable is lagging, which variable is leading, it will not tell. Wavelet coherence will tell me. And what is partial wavelet? Now, just understand wavelet is a correlation. So what is partial correlation? What do you mean by word partial correlation?
Ma'am, in partial correlation, we will be keeping some factors as constant.
Which factor as a constant? Which factor as a constant?
Ma'am, the independent variable, if there are independent variables, multiple independent variables, then we will see the one independent variable effect on the
No,
dependent variable
no,
keeping other.
no. This is not partial. Okay, I gave you one example for, let's say I am having a correlation of, I gave you one example for attendance of the student. If suppose I say that today the attendance is weak, that means less number of students turn out into my class. And secondly, I see that every student, whosoever is coming in the class, is carrying an umbrella. So I can say that there is a correlation between umbrella and the attendance, isn't it? I can make the relationship. Now, why the students are carrying umbrella? Because it's a rainy season. So that means rain is a control variable between these two things. If I am going to compare the correlation of the umbrellas and attendance, so rain is a control variable. If I am going to take out the effect of rain, in that case, what I am saying, if rain is not there, that means I can say there is no relationship between the attendance and your umbrella. Similarly, let's talk about this part. Uh, Aluminium and your carbon only, right? I'm talking about, we have three variables: carbon, your aluminium, and your, I have taken nickel. Okay, that means I have three variables: your aluminium and nickel and carbon. Now, can anyone can tell me what is the relationship between these three? I told you in the starting there must be some theory. What is the relationship between these three?
Ma'am, as you have said it earlier, carbon will be a
Hmm.
dependent one, aluminium
Yes,
will be an independent one,
and
and the
nickel
nickel
is an
controlled one.
independent. Yes, it's a
Independent but
control.
controlled.
But why? I told you the reason that we are towards the decrease of carbon emission. That means we always try to decrease the carbon emission, and carbon emission will decrease when more and more electric vehicles will be there in the market. And whenever the electric vehicles are there, it means batteries are to be produced, and nickel is used to produce the batteries. So that means, and batteries, your car is made with the help of aluminium. So that means if more and more battery, aluminium and carbon is having a strong relationship. Why? Because we are saying that produce more and more batteries. If we are producing more and more cars will be produced, and they both will having the more correlation. But if we take out the nickel from these two parts, that means we are not producing more batteries. If batteries are not there, aluminium is less, that means less cars are being produced, so there is no relationship between carbon and your aluminium. So that means nickel is controlling the relationship between these two. Now we will prove it with the diagram also. If I am going to just make a wavelet, that means wavelet coherence, correlation between these two, you will see that it will show that these two are having a high correlation. But when I take out the effect of nickel from these two, that means I just want to see how these two are related to each other. If nickel is not there, for example, if I am saying I am your friend and the third person is my friend. So in this way, you and the third person are related to each other. So you are having a correlation. Some relationship is there between you and the third person. But how the relationship is there with the third person? Due to me. If I am going out, then if there is a relationship between whatever the relationship is left between that third person and you will be named as your partial correlation. Suppose due to me your correlation is 50%, but if I am out, your correlation can be 10%, it can be 20%. That means after taking out the effect of the third variable, what is the remaining correlation between the two variables? That is known as your partial correlation. Got this thing? What do you mean by partial correlation?
Yes, ma'am.
Okay, now let me go with the wavelet.
मैम अगर आपने जैसे इसमें बताया कि अगर निकल को हटा देते हैं या आपने जो फ्रेंड वाला भी एग्जांपल कोट किया, तो मैम क्या जरूरी है कि उस केस में कि अगर जो कंट्रोल वेरिएबल को हटाते हैं तो जो कोरिलेशन जो दो वेरिएबल्स के बीच में बचे वो हमेशा डिक्रीज ही होगा, इंक्रीज होने के चांसेस नहीं है कि अगर वो थर्ड पर्सन जाता है तो?
It can be, but 99% theory says it will decrease. See, if I and you, I am the third person and you are the first person. If we are having the strong relation among us, and if I am adding the third variable also, So the relation will increase or decrease? Just tell me. I and you are having the strong relation. Let's say 80% relationship is there between me and you. Now
Yes,
third
ma'am.
person is also adding to us. The
Hmm.
relationship will increase or decrease? Our bonding will increase or decrease? It will not, it will never decrease. It will increase. Now the bonding is among three people. It will increase. In regression also we have learned that if one more variable is added, your adjusted R square increases.
Ah,
Got it? Now I
yes,
am taking the effect of the one variable out.
yes, ma'am.
Now it will now think the other way. I am saying that if I and you are having 70% correlation, one variable is added, so my correlation becomes 80%. So
Yes,
that means now three variables are having the correlation of 80%. Now I want to take out the second variable out. So my and yours and mine correlation will decrease. It will not increase. If it remain, it can remain same also. I'm not saying it's always decrease. It can remain same also. It can happen that the third variable that is having, that is adding to us. So they are having the no relation neither with me, neither with you. So our relationship is 70%. After adding him also, our relationship is 70%. So if whether he is added or whether he is taking out, that means we are removing it, our bond remains same. So just we have to see the partial correlation says that whatever the answer of wavelet is there, whether the wavelet answer continues after removing the third variable or not. Okay, so we have two packages. Whenever we will be doing the wavelet, we use it two package. The first package we can do with wavelet form. And second package, both will give you different results. Second package is by wavelet. Now, what is the drawback between wavelet comp and wavelet? I have given you one command plot.ts and another command. See, I have given you one command plot.ts and another command I gave you ts underscore plot. What is the difference between these two? We have done the diagram with these two diagrams and commands are normally same. It is also saying plot the time series graph. It is also saying the plot the time series graph. But presentation was different. What was the difference between these two?
हम जब हमने सेकंड वाला कमांड यूज किया था ts_plot वाला, तो इस केस में हम बेहतर तरीके से नेविगेट कर पा रहे थे रिजल्ट्स को हर एक
Plus,
पॉइंट पे.
second thing was that when we were using this plot.ts, we have number of observations. That means what is the answer at one observation, second observation, third observation. So it has not given me the x-axis in years. It has given me x-axis in your number of observation. But when we use ts underscore plot, we get the answer in years. The same difference is between wavelet comp and biwavelet. If we are going to use the wavelet comp, it will give you the answer in number of observations. But if you are going to use biwavelet library, it will give you the x-axis in years. That means time period is shown if we are using biwavelet library. Instead of time period, number of observations is shown when we are using the wavelet comp. Got this? Got the difference? Now can I start?
Yes, ma'am.
So first is your library wavelet comp. First go with wavelet comp. Now we have already imported the data. So what I have done, we are going to see the wavelet is always done with two variables. So I have taken again the first variable to be carbon and second variable to be aluminium. I have defined it as X and Y. And if you remember the this zoo file that we did yesterday, I have given that date is equals to as dot date and the name of the variable and $ date. If you remember the zoo file. So what I have done, I have combined all this and store it in my data. Now, if you have to, if missing values is there, just remove the missing values with the help of na.omit. Always try to use this command either after this importing the data set or before doing any analysis. Now, first of all, see cross wavelet. The sign will be X. This is a cross WT, cross wavelet. Now, if I'm going to make the cross wavelet, now in this command, you can see I have taken the lower period as 2 and upper period as 128. I can change this to 256 also, because normally a stock market works around 250 days in a year. So we can change it to 256. You can change it to, you can customize it up, matlab, depending on you how you want to show the time period. Okay, now let's make the diagram. Now you can see this diagram. Now it is showing the cross wavelet, and you can see it's 200, 400, 600, 800. Number of observations are being shown. And if you will see these arrows, these are the arrows. Always remember we have four kinds of arrows: rightward, leftward. If rightward is there, positive correlation. Negative, leftward is there, negative correlation. If arrow is upward and rightward, so it means the first variable is leading the second variable. If it is downward and rightward, positive correlation, second is leading the first variable. If it is upward and leftward, so that means first variable is leading the second but negative correlation. If it is downward and leftward, second variable is leading the first but negative correlation. For this thing, you will remember these 4 points. This is your cross wavelet. So, and you can see these white counters you are able to see. So the area between these white counters is your significant, and area beyond this white counters is insignificant. So we don't have to consider insignificant, we have to just consider the significant part. And over here you can see blue means your zero. If you have seen, these heat maps are always made with the help of your environment. Your sun is dark, that means it's orange color, that means heat is more. Your sea is calm, and sea and sky are always seen by the blue color. So whenever the situation is calm, calm means no relationship, it will always be shown by the blue color, and high relationship, strong relationship will always be shown by the orange color. Got it? Now you can see over here, you can see that high correlation is there during the short period of time. This is we have divided the complete year into 120 days. We can divide it in 256 days also. So that means you can say that during the short run, more correlation is there. If something is happening, other will also be affected. But as the time passes, the relationship decreases. We have proved this thing in the Boric and Kilmaz also. In the short-term time period, your connectedness was more, and as the time increases in the long term, the connectedness is very less. So over here, long term, you can see relationship between these two. What do you mean by relation? Connectedness between these two is less, and in the short run, the connectedness is more. Now, if we move to your wavelet coherence with the same thing, I'm just making the diagram for the wavelet coherence also. Again, it will stimulate. Instead of 2 to 128, you can take 2 to 1 to 56.
Ma'am, in wavelet, we have only diagrams. We don't have
Yes,
any
yes. We
figures.
don't have, we no figures are there. We don't have any statistical part in this.
Okay.
Okay, now let's make the image. It's through heat map only, but how can we show? See, in quantile wavelet also, in the diagram only, you can drag it and see. But for each and every day, it's difficult to write it. So wavelets are always through diagrams. WCC. Now you can see this diagram. This is a wavelet core. Now you can see the time period and your arrows are here. Little bit because the diagram, your figure, you can just, I can just. Now see, the arrows are leftward. So that means negative correlation between your aluminium and your carbon. Negative correlation is there. You can see these counters. We have to see only the counters which are highlighted with your white color. So you can see in the short run, no correlation, but over here at the medium term, a little bit correlation is there. Now we can do the same thing with your biwavelet also. So instead of your this wavelet comp, you can go with the biwavelet. Let me see whether okay, I have to take out some other library. Now, biwavelet, we can do it with biwavelet also. We have imported the data now. In that case, I have to write it over here. Data and date, data and variable. First variable is your carbon. Second variable, let us take to be SCIGA, and third variable to be
Here we can take more than two variables.
no. You
Here X,
cannot take.
Y.
That's why, because I want to show you the partial correlation also. Na partial means taking out the
Okay.
effect of third one. So that's why I've just named it XYZ. We will see for two variables, and after taking the third, removing the third, we will show the partial correlation. So these are what I'm saying, C bind from the first to the last observation. We are not going with the cross variable. And let's go. Now see, the different diagrams are there for this. I'll just show you partial. Okay, let me.
Excuse me, ma'am.
Yes.
Ma'am, what is the difference between these two packages? One is wavelet.com and another one is biwavelet. When to download
Both,
or when to install which one?
it's up to you. It's up to you. In some of my papers, I have used the wavelet com. In some of my papers, I have used the biwavelet. For example, I just show you one of my papers. There is one paper of resource quality. Now see these diagrams. These diagrams are with wavelet com. These diagrams. If you will see, these are from, this is cross wavelet, and then I have made the wavelet com. Now if you will see this diagram, you can see these arrows. We have to see only these white contours. That how the relationship is there. And after that, I have taken the partial wavelet. This is your partial wavelet. This is a PWC, partial wavelet correlation between carbon emission and Euro GSD after taking out the impact of Japan. Over here, partial wavelet between CE carbon emission and JPY. That means Japan in the Japan currency after taking out the impact of GBP, your Great Britain pound. Similarly, I have taken the partial wavelet correlation between CE and GBP after taking the impact of Australian dollar. Partial wavelet correlation between CE and Australian dollar after taking the impact of Canadian dollar. So in this way, we can make the wavelet partial wavelet, and then I applied the wavelet correlation. Now you can see over here, this is a lower limit, this is the upper limit, and this is the correlation between these two variables, carbon emission and Euro. And you can see over here, that means at this point there is a positive correlation, or you can say near about the same correlation, zero correlation. You can see it's touching zero. And after the 32, that means if I'm taking 32 as a medium term, after medium term it increases. Over here you can see it starts from zero in the short term, no correlation was there, but the correlation becomes negative, and after your medium term, that means it increases. All the diagrams over here, zero correlation in the short run, in medium term it turns out to be negative, and in the long run it turns out to be positive. Over here it was negative, and throughout in the long run it becomes more negative. In all the diagrams you can see, this is the individual diagram. That means I have taken the wavelet correlation between these two. I can see the combined correlation also, how Australian dollar, I have 5 variables: Canadian dollar, your Australian dollar, GBP, your JPY, and Euro. I can see the combined correlation between these 5 variables and carbon emission. So whenever I'm taking the combined correlation, it will always be positive. It will never be negative. So it
मैम
depends.
इसको सॉरी मैम, इसको मैम उसमें करके दिखा दीजिए, आर में कैसे करेंगे पार्शियल और ये वेवलेट कोरिलेशन.
Okay, yep. Just run this command and wavelet. Okay, I'll just show you the optimized one. By wavelet. This, okay, let me do this again. Let's just saying the brick wall mod was returned. WX could not find the brick wall. Let me check the command. This is the wavelet form. Wavelet orange, space wavelet, by wavelet. Okay. Yeah, and then And this is for your biwavelet clock. See, in this you can see the ears, but in the previous figures you are not able to see the ears. See, it was a number of observation. And second thing is that you can see the starting of the days to second day, third, fourth day, eighth day. That means your period is starting from lower till upper. But over here, your period is starting from above till lower part. So these are the two differences between your if you are making the wavelet coherence by your wavelet comp, and if you are making the wavelet coherence with your biwavelet. First of all, years, and second the period. Even you can see the counter, this part, this gray part. This is U-shaped, but in that case it was inverted U. It was, see, you can see inverted U, this part, inverted U was there. So these are the difference between if you are using biwavelet or wavelet comp. And if I'll make the partial wavelet, let me see the partial wavelet. And this will be a partial wavelet. Error in we have to N brands have taken 10 partial wavelet model PWTC T1 error in check X2. I think some problem is there.
Ma'am, sorry to interrupt. Don't you think that the interpretability of the diagrams are very uh, problematic because the arrows are too small and sometimes the
It's not problem. It's a problem with the variables. The variables that I have taken, they are not properly correlated with each other. So that's why you are getting this kind of diagram. If you are taking any other variables, your diagram will be a proper one. I have made all these diagrams that I have shown you my paper. I have made with these only. So depending on the variable to variable. Just try it with some other variables. You will get the proper diagram. I
ma'am,
think
please
there is
do share
some.
the codes, please.
Yeah, I'll share it. I'll share all the codes. I'll share the complete file of R. All the wavelets, your regression, your this quantile on quantile, your TVP, that means dipole, boric. I'll share all the codes. So I think some problem is there with this. Otherwise, we are able to make the diagram. Let me see if I can get the diagram. Let me just check this. I can show you the correlation with this. Yes, some problem is there with the codes. Modweb. Okay, I have to run modweb first. I think some problem is with the codes. Yes. I have to recheck these codes, then I'll get back to you. Because modweb is not there.
Okay.
Yes, some problem is there. I think
मैम कोई
Ma'am,
पैकेज तो
library.
नहीं है, पैकेज
yes,
कुछ?
ma'am. Which package is not? Yes, ma'am. Probably this
I
package is
think
not
yes, yes,
loaded.
yes. Maybe I have not loaded any one more package over here. Yes, now it's in. Now see the diagram. This is wavelet correlation. And we can make the wavelet multiple correlation, that if I am taking all the variables all together. So again, I have to just library wavelet. And if I'm going to again define it, it will. And if I'm going to plot it, now you can see this is for wavelet multiple correlation. That means if I'm taking all the variables all together, and you can see the result is positive, the result will always be positive. But when we are seeing the simple correlation between only two variables, see these two variables are behaving negatively. There is a negative correlation throughout. When you will write the research paper, your things will be much more clear.
हाँ यस मैम। मैम एक बार पार्शियल भी चेक कर लीजिए, अब हमने वो डाउन वो कर
Part,
लिया नोट। जी मैम।
partial check it. Let me. There is some problem in this, in partial wavelet. I don't know why the problem is there.
Ma'am, please share all these codes. Actually,
Yes,
we are
yes.
not able to write this.
Yeah, I'll share, don't worry.
Yes, ma'am.
Yes, now it's okay.
थैंक यू सो मच मैम, बहुत टाइम लगा मगर
Mhm.
बन रहा है इसको। थैंक यू मैम।
See, this is a partial wavelet between the carbon and aluminium after taking the effect of nickel. As I told you, na, due to nickel, aluminium, the effect of these two are a positive correlation only due to nickel. If you take out the effect of nickel, there is no correlation, everything is blue. There is no correlation, and you can see the arrows are visible over here. You can see the arrows are visible over here. Since there is no correlation over here, that's why you are not getting any arrows. The arrows are insignificant right now over here. It's beyond this counter. That means this portion, that means this white line. The area between within this white line is significant, and area beyond this white line is insignificant.
So
And
these
arrows
arcs,
are,
Is
the
boundary tip
area
R?
beyond these arcs are insignificant area, right?
yes, arrows are in the insignificant area. And if within this area you will get the arrows is upward, it means positive. That means rightward positive, leftward negative, arrow upward the first variable is leading the second. If arrow is towards the downward, second is leading the first one, or you can say first is lagging.
Ma'am, here some
First,
arrows are visible in the small circle. Some arrows are
yes,
visible.
yes, yes. Where? Where are the errors?
Ma'am, there are some here at the top, ma'am. A few
Hmm.
are there at the top.
Yes, ma'am.
These is a
Few.
At the
correlation is
top.
there,
Yes,
na?
yes, yes.
These are arrows, na? So
Yes, ma'am.
these
Yes,
are the
yes, yes.
arrows. Yes, you can see the
Yes,
arrows
ma'am.
over here. Also, you can see the arrows.
Yes, ma'am.
You see these arrows. Since no
Yes, ma'am.
correlation is there, so that's why less number of arrows are there. Otherwise, arrows are
Ma'am,
visible.
I have a question.
So, ma'am,
Actually, you said earlier in package that is the
Hmm.
counter or the circle, white circle. Here it is shown as black circle. Within this circle or within this
So
particular
it's up to us now. Whenever I am giving command, I'll give the command that show the circle with black, show the circle with white, show the circle with gray.
okay. No, ma'am. Actually, I'm talking about the circle as well as the area. You are talking about the
Yes,
area.
it's up to us
Yes.
now that how we are saying to show it. And even see the arrow length should be 0.03. Arrow length should be 0.08. See, see over
Yes,
here.
ma'am.
I have
But
written the color of the cone should be gray. So that's why you can see it's gray color. If I write it
okay,
should be
ma'am. But
black or white, it will show me in white color.
yes, ma'am. But
ma'am, can you
my
show the
question is
diagram
that,
once more? This partial
ma'am,
wavelet coherence.
yes, yes. Zoom this diagram. And ma'am, the diagram has two parts. One is properly visible, and another
This part is
is
partially visible.
yes,
This
partly
is
visible in this part.
this is insignificant.
Now,
This
Okay,
is
ma'am,
and
insignificant.
ma'am, now,
but
Within this area is significant.
within this area, but you earlier said that this within this circle, this area is significant. But
Hmm. Now what they have
now,
ma'am,
done, they have
ma'am, can
shown
I,
it that this is the there is a high correlation over here, but where the blue portion is there, low correlation or zero correlation. You can see the heat map.
okay, okay.
ma'am,
If
can I
red color
ask
is
one
there,
thing?
yes,
Ma'am, since this is a 3D depiction,
this
now
is
if we
2D.
look,
This is 2D.
okay, 2D. So here, global carbon emissions, that is GLCRB,
Hmm.
and there is one more variable that is
Aluminium.
acha, aluminum. Okay,
This is aluminium and this is nickel.
this is metal.
These are metals. These two
Okay,
are metals. We are going to see if we are taking the metals, the carbon is emerged. That means carbon emission is there. So what is the impact? What is the relationship? If the more and more aluminium is extracted, whether more and more carbon emission will be there or not. If more and more nickel is extracted, if I take out, first of all, I took the relationship between these two, how carbon and aluminium are related to each other, whether there is a relationship between these two are there or not. So I find out, yes, there is a relationship between these two. Then I see that if nickel, because we produce more and more aluminium, why? Because we have to make the batteries, and nickel is used in the batteries. Now, if I'm not going to produce the nickel, that means batteries are taken out. So in that case, we are finding that aluminium and carbon are not having any relationship. The relationship exists due to the nickel only. More and more batteries are produced, more and more cars are produced. So that's why there is a relationship between carbon and aluminium.
okay. So that means if there is 1 unit of you can say nickel extracted, then
Hmm.
there will be more carbon emissions,
Yes,
and as well as aluminum, there will be an effect on aluminum also.
yes,
Okay,
yes, yes.
okay. And now these particular wavelet will help us in understanding that how this correlation is increasing or decreasing over a period of time. right?
No, it will help you to just find out the pure correlation between aluminium and carbon after taking out the effect of nickel.
Okay.
The example that I gave you, I and you are related to each other, right? But how I am you are related? Maybe due to the third person. If that third person is not in our relationship, that means there can be that the relationship between me and you is reduced. For example, it's बहुत ही simple example. Let's say you and your wife are related to each other. You are related to the parents of your wife due to your wife. If somehow you are divorced, that means you and your wife are separated. So will the relationship between you and your in-laws will be increased or decreased?
Okay. Mhm.
Ma'am,
That means
this
you
partial,
and
yes, ma'am.
your in-laws are having relationship due to your wife.
Mhm.
Ma'am,
So I'm
therefore the
taking out your
partial,
wife.
So that means we are taking nickel as a constant, right?
We
That
are
if
control variable.
control
ma'am,
variable, right?
therefore, ma'am,
Yes.
therefore partial wavelength coherence is nothing but a partial correlation.
Correlation. Yes. It's
Yes,
same as
partial
partial
correlation in the
correlation.
time frequency domain.
Yes, in the time frequency domain.
Okay, ma'am. Ma'am,
And
can you
So
show
so
your
so year wise, what can be the policy implication from this graph, ma'am?
so year wise, if you will see that starting from 2020 till 2023, the relationship between your aluminium and carbon, there is no relationship. Throughout this year, there was a relationship only due to your nickel. And if you will see, if you have heard about COP, right now I think COP 29 is there. Do you understand what is COP?
Conference of Parties for
Conference of,
UNFSC's
yes, US. So
United
that
Nations
means
Framework.
why what we are doing for COP, we are trying to reduce the carbon emission. And after the meeting of COP only, we are into the electronic vehicles. That means
Yes,
we
yes.
are giving emphasis on the electronic vehicles. So that's why I have taken the period from this to this, that, and I have seen that whether the relationship between the metal and non-metals with the carbon emission. So I have seen that aluminium and carbon are not having as strong relationship as carbon and nickel. Their relationship is due to nickel only. If nickel is not there, they will not have any relationship throughout the time
Okay.
Ma'am,
period.
ma'am, one question is there. Ma'am, how to find the existence of a control variable? Like in this case, you have took
From
nickel
theory, from theory,
because it's quite difficult to extract out those
yes,
control variables.
yes, from theory you will be learning. Now,
ma'am,
how
can
can
you
you say that gold is a safe haven? How can we say that gold is a safe haven? But we normally say gold is a
Hmm.
safe haven. Everything can go down, but the gold will not go down. That means with the time, if you are investing in gold, in future you will gain only. You will not be in a loss. That's why I say that you are in a safe haven.
ma'am, can you
So
open
how?
your quantile and
Yes.
quantile regression model in your paper? You have presented in a paper, na? Quantile and quantile regression. The diagram is different from your plotly or in
Because
R
that
actually.
they were different variables, I think.
No, ma'am,
Is,
actually the
ma'am, is
diagram
there
is
any
look like
difference between a controlled variable and intermediating variable? Intermediate variable.
For if whenever we are writing the equation, we treat it both as an independent variables only. But yes, theory says the different thing. Even I don't remember in which paper I have used this, not this. I think computational economics, I think I have used. This diagrams you are saying.
yes, ma'am. Yes, ma'am. This diagram is look like different, na? In your R, these diagrams are
These diagrams are from MATLAB.
okay, ma'am. And how to interpret this diagram based on this color?
See, these are the colors, na? If
Yes, yes,
negative is
different
blue
types of
color is
colors.
there,
Yes,
blue
yes,
color
yes,
is
yes.
there, so negative relationship. This color 0, and as the color increases, the 70% relationship. You can see over here. Here is quantile of EPU. Here is a quantile of financial, and these are the coefficients. So at
Okay,
different
ma'am.
quantiles, what is the coefficient? What is the, you can say over here at when it is in a bullish market. That means when EPU high changes are there in the EPU and high changes are there in your financials. You can just see over here. So the coefficient is increasing. That means high correlation is there.
Yes, ma'am, but some coefficients are invisible due to this high coefficient. That is the
No,
behind this high correlation.
no,
Some plots
every
are there, na?
coefficient is visible.
Yes, but something is there. Yes, I'm talking about in this chart where blue is
Hmm.
more actually
In this, there is no
lower corner.
relationship
Yes.
between these two. But if you will see the effect of EPU and your personal goods, you can see the relationship is zero. The colors are
Yes,
different
ma'am.
in both the
In the
cases.
right in the right hand side, the diagram is properly visible, but in case of left hand side diagram,
Like
it is
over
not
here
properly
also,
visible.
yes, it is over here also. It's properly visible. You can see what is not properly visible. Your blue
Actually,
color
ma'am,
is
I'm talking
saying
about
negative.
where the quantile of EPU is more than 8 as well as the quantile of financial is more than 8. This part is not
Hmm.
properly visible, na?
No, it's visible. See, right now, this is a picture. But when we make the diagram, it's a 3D diagram. We can just put our arrow, as I gave you in R, na, we can just find it out like this. For example, over here, you can see the arrows, you can see the impact. Everything will be written over here. But whenever I'm going to put the same thing in my paper, so if I'm going to put it in my paper, I'll just copy it and then place it in the paper. It will be a static diagram. You cannot
Okay,
move
ma'am.
the
Okay,
cursor
ma'am.
over there. So that's why
Okay, ma'am.
this,
Therefore, we can change. We can see the impact in between different among different
yes,
quantiles. Okay.
yes, whenever you are making the diagrams in MATLAB or R, you can just scroll your cursor and see the impact at different points. And then you can write it in your paper. But whenever we are pasting the diagram, cursor will not be there, na? It will be just a printing part is there. So that's why over
Okay.
here
Okay.
you
Okay.
cannot see it.
Okay, ma'am.
So diagrams
Thank you.
are clearly visible in each and everything.
Okay. Okay, ma'am.
I think these diagrams are from MATLAB only.
Yes, ma'am.
These are MATLAB.
Yes, ma'am. Ma'am, in
So
your
and
first class, you said that event study methodology can be done in R. Can
yes,
you
Yes, ma'am.
I
I
can
know
just
share
that.
show you
the
the
codes?
quote.
Okay, ma'am. Thank you.
Yes,
Thank you.
ma'am.
So any doubt to anyone?
Ma'am, do we have something like quantile wavelet also?
Yes. I'll just show you the quantile wavelet.
Which one, ma'am?
I'll just uh, this is wavelet quantile correlation.
Ma'am, screen is not shared.
Okay. This is your wavelet quantile correlation.
Okay.
Now you can see here the different days are written. That's what I say. I made the whenever I was giving the command, I have wrongly given the command. Here it should be periods, and over here it should be quantile. These are the quantile. These are the periods. So
Okay.
now you can define the short run, medium run, and long run at different quantiles. So you can apply the quantile in anything, maybe this ARDL model, Ganja causality model. You can in wavelet, in
Ma'am, is there any
regression.
standard book or any research paper to understand this basic concept of quantile, which is applicable in ARDL panel or anything like your wavelet quantile correlation and
You have to search for the research paper only. There are research papers for each and everything.
But ma'am, in research paper, they are not provide the details or the code, or you can say that.
No codes. Obviously, in research paper, they will not provide the codes. But right now, these days, there are various research papers where the codes are also there. If you will see at the end of they will give you the data sheet also. They will give you the codes also. In the appendix, most of the journals are giving us data
Okay.
set as well as codes. So, any doubt to anyone regarding any topic?
Ma'am, hedge ratios, if you can show.
Hedge ratios. You have my paper now for hedge ratios.
Yes, ma'am.
Because for the commands, right now I have to search where I have saved the command.
Ma'am, can we conduct more such workshops in near future
Yes,
as
ma'am.
well?
Part 2 of this, ma'am.
Yes,
First of all, are you able to get something from this workshop?
Ma'am,
Yes,
Can
so
can
much,
very
we
much,
ma'am.
very much.
can we open the cameras?
Sure, ma'am.
Now, can you share how much you were before this workshop and how much you are now after this workshop? Maybe
Ma'am, I was at
1%
a
you have
nil
gained,
point.
Ma'am.
Ma'am, I was at a
Oh.
nil point in time series analysis.
and now at what point you are?
Ma'am,
Ma'am,
yesterday's sessions I have missed due to some family outings. So
So
yeah,
you
I have
can
to
see the
watch those.
recording.
Yeah, I have got those recordings, so I would be learning from that what you have taught in yesterday's session. But overall, it was a quite fruitful session for me to
and ma'am,
learn time series analysis.
same here, ma'am. Actually, I was reading research papers, but was not able to, understand this. I mean, in detail, you have explained and you took questions also. Usually in workshop, what I have seen that resource persons, they don't take so many questions. But ma'am, thanks to you, you took so many questions and answered, ma'am. Thank you so much, ma'am. Think there is some internet problem.
Hmm. And what about others? Survey, are you there?
ma'am, all the sessions are wonderful,
Yes, ma'am.
especially
It has
yes.
been exponential learning from day 1 to day 7. So
Right.
much, but like last 2 days, yesterday and today, is so much learning. Like I couldn't write so fast. So many things were there. So I will have to see the recording again. But it has
See,
been really, really great. Thank you so
research
much,
is
ma'am.
very deep. Research is very deep, very deep.
Ma'am,
I
I have
cannot say
attended
that.
your one session in Vanasthali Vidyapeeth last year. That
Okay,
also
Pratik.
motivated me to take this session on in an online platform. You taught us really
Okay,
well. There you have taught us on R and Stata.
on Stata. But that
Yeah,
was only
last
two
year.
days now. But
Yes.
see,
Ma'am,
whenever
thank you
we
so
are
much
off,
because this is something which we really need because of our research purpose, paper purpose. Ma'am, please one
so
request. Please keep this
yeah.
info.
What is your request?
Just open the online recordings for one more month as you were.
Yeah. That's not a problem. That's not a problem.
It will be for 3 months.
The
Yes,
recording
ma'am.
is
Yeah, ma'am.
not a
Thank you so
problem.
much.
Thank you, ma'am.
The only thing is that after seeing the recording also, you write something, then it will be fruitful. If
Yes,
you're
ma'am.
not going to write anything, 3 months is just a small span. 3 months, 4 months, even 1 year, just a small span. It's just gone.
Thank you. Thank you, ma'am.
So just read the research papers, you will be able to learn the thing. It's not that I am having any book, I am having something. I am also reading throughout. I am also learning throughout.
Yeah, ma'am, it will very helpful.
If I'll see maybe 6 years back, that's why I told you in workshop also, na, thanks to COVID, that COVID, the COVID forced the college that I should take the workshop, and that's why I'm here, and that's why I'm learning.
Yes, ma'am.
Now, ma'am, we
And
should thank the college also, ma'am.